The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everybody. So welcome to this webinar on the innovations in ports. This morning, we will talk about the several innovations that we have developed and deployed at the port of Piraeus. And first of all, let me ask you, who are you? So who are the attendants? So I will give some 2 minutes just to make sure that all of you can answer. I see that 30% have already voted. We are at 50%, so still some to go. I invite the remaining ones to still vote, 65%. So nobody votes anymore. Only 65% did vote. So yeah, some remaining ones. Okay, still some voting. I give some 5 seconds more. Okay, I close the poll and I can now share who all of you are. So we see that 13% are port operators, 13% are port service suppliers, 22% are research organization, 13% consultants, and 39% others. It would be interesting to know who are these others, but maybe in the Q&A we will see this. So now let me introduce Dr. John Candelopoulos, unit leaders in logistics and maritime and smart integrated systems at Hisense Group of ICCS. John Candelopoulos holds a Bachelor of Science in Computer Information System from the American College of Greece, a Master of Science in Software Engineering from the University of Nottingham in the UK, and an MBA from Durham University in the UK. He has more than 20 years of experience in system analysis, software engineering, and data networking. He was the network project manager for the Olympic Games in Athens in 2004. And has participated in systems design for several banks and telecommunication organizations. John was a member of the IT team of the Piraeus container terminal for 10 years, participating in all major projects of the company. Currently, he is in the Logistics and Maritime Unit, leader for ICCS. Welcome, John.
Thank you very much, Thomas. Let me show my screen. Are you able to see my screen?
Yes.
Okay, thank you very much. So let's begin a little bit with the introduction about the COREALIS project. The COREALIS project is a project funded by the European Union under the Port of the Future call. It has started on May 2019 and is supposed to end next year at the end of April. The coordinator of the project is the Institute of Computers and Communication Systems here in Greece, in Athens. And the project consists of 17 partners from 9 European associated countries, including Switzerland. There are 4 research institutes in the consortium, 5 ports, 4 industry companies, 3 SMEs, and 1 ITS organization. And the living labs are taking place in 5 European port cities, including 3 out of the top 5 ones. The ports that are participating are the Antwerp port region, which is number 2 in Europe, the Piraeus port in Greece, with number 4 in Europe, the Valencia port in Spain, which is number 5 in Europe, and 2 medium-sized ports, the Livorno port in Italy and the Haminakotka port in Finland. COREALIS' visions and main goals is to propose a strategic and innovative framework that's supported by a number of disruptive technologies, including data analytics, Internet of Things, next generation traffic management, 5G emerging networks. The Livorno port is one of the first ports in Europe that has a 5G installation. And all this can help cargo ports to face their current and future challenges. We are targeting towards optimization of port operations, the reduction of environmental footprint, the increase of efficiency, and the reduction of traffic within and around the ports. Sustainability and socio-economic development of the ports is one of our main goals, and so far, with the innovations being completed at this point, we are very close to the targets that we initially set in the project. The innovations that we're developing within COREALIS are a collection of software platforms and feasibility studies, as well as a Port of the Future series game that allows for decision making. So let's go through one by them, making a short introduction. So the Port of the Future series game is a tool that has a digital version that can support the decision making process of port stakeholders in port communities. The RT-Port is a 5G-based application that allows for smart terminal operations and the placing of bulk cargo within the yards of the port. A brokerage platform that allows asset sharing and human resource sharing among different stakeholders operating at the port. Port mode is an optimization planning tool that's mainly targeted to medium-sized ports and allows the changing of the layout of container yards within terminal operators. And the innovation incubator is actually an initiative to make the port an innovation hub in the area, and allows for the cooperation of different companies and different SMEs and startups in order to make the port even more productive. A track appointment system that is a reservation system for trucks that are arriving at the port gates looking to decrease the traffic that is taking place over there. A just-in-time rail shuttle service that is a feasibility study that shows what are the benefits from having a rail shuttle waiting for a number of containers within a port that allows the shift from road to rail, making the amount of emissions much less in the port area. A cargo flow optimizer that allows the optimization of cargo flows arriving from the ocean and heading towards the mainland and shifting traffic from road to rail and inland waterways via barges. The Predictor for asset management, which is a machine learning algorithm that allows for predictive maintenance on yard equipment operating within container ports. And finally, a green cookbook that is an energy assessment of the Port of Piraeus in this project that allows us to identify potential of replacing current power consumption from traditional ways to renewable energy sources, as well as other initiatives that allow the Port of Piraeus to reduce the environmental footprint. The innovations that we are developing in COREALIS will be tested in these 5 ports. As you can see here is the matrix of the testing that's going to take place. So in Valencia, we have the track appointment system, the just-in-time rail shuttle, and the innovation incubator that's going to take place via the introduction of a hackathon. In the Piraeus port, we have the Predictor assets management, the energy assessment green cookbook, and the Port of the Future series game, which you are going to receive some more details within this webinar in the next presentations. In the Livorno Living Lab, we are testing the port mode application, the RT port, and the Port of the Future series game as well. In Antwerp, we are testing the brokerage platform and the cargo flow optimizer. And finally, in Haminakotka, we are implementing a track appointment system, the port mode application, and the Port of the Future series game. At this point, I would like to end my presentation by showing you a video that we have prepared in the COREALIS. It's also available on our social media and YouTube, and we are quite proud of it. So I'm giving the floor to Julia in order to continue with the presentation of this video, the introduction of this video.
Thank you, John. And now the video. So we are now looking starting with the main part of the presentation of the webinar. And for this, I welcome Mr. Stavros Tsagalas, IT network engineer at the Piraeus container terminal. He's a senior level professional with more than 15 years of engineering and operation experience, especially in analysis, design, implementation, and optimization of next generation IP networks. He is responsible for architecture and design standards of major internet service providers in Greece and general internet connectivity. Stavros is a member of the IT team of the Piraeus container terminal, participating in all major IT projects of the company. Welcome, Stavros, and the floor is yours.
Thank you very much, Thomas. Let me. Okay, are you able to see my screen?
Yes, Stavros.
Everyone for attending. We're going to see a brief introduction of the Port of Piraeus Living Labs. We have here an aerial photo of the port. From right to left, we have Pier 2 and Pier 3. Port of Piraeus is the first port in the Mediterranean and the fourth port in Europe in terms of container throughput. It is one of the fastest growing ports worldwide during the last decade. And PCT business plan includes further development that will allow Piraeus to directly compete with North European ports. Some key facts: the ownership is 100% by COSCO Shipping Ports Limited. Container terminal Pier 2 and Pier 3 are under concession for 35 years to PCT. PCT operates on 24/7 basis a fleet of 170 trucks and 19 cranes, and it is located in an urban work within a 20-kilometer radius. Now, the crane operation is electricity-based, making the port a heavy consumer of power. Now, Port of Piraeus is involved in 3 living labs, as mentioned before. First one is the Predictor, which is an asset management tool. We have the Crane Cookbook, which is an assessment tool. We have also the Port of Future series game, which that is a simulation tool. So, COREALIS Predictor is a preventive maintenance tool based on machine learning algorithms. We use historical real-time data that are monitored and analyzed, trends identified, and optimization algorithms developed and trained. So what we accept of the Predictor are the data-driven preventive maintenance schedule, a data-driven schedule of purchases of a new spare parts, a data-driven schedule yard equipment for just-in-time inventory. From the Green Cookbook Living Lab, it's a feasibility study for the power consumption patterns and the potential of introduction of renewable energy sources in the Port of Piraeus. What we accept from this is to have an energy assessment framework, also a feasibility study of replacing the existing diesel fuel fleet of yard trucks with a sustainable electric propulsion trucks, and the feasibility study for introducing renewable power sources to the grid. The Port of the Future series game, as already mentioned, is a simulator. The scope is to enhance social aspect and acceptance of the port and to monitor social economic adoption of the port in the surrounding urban environment, to embrace circular economy models in its port strategy and operations, to reduce the port total environmental footprint, improve operational efficiency without enable the port to take informed medium-term and long-term strategic decisions, and last, to raise awareness of the port city challenges and support stakeholders to achieve development with a positive environmental impact. So thank you very much for your attention. Thomas, back to you.
Thank you very much, Stavros. And it is a very good teaser for the introducing the next speakers. After each presentation of the innovation, there will be time for the 1 or 2 questions more at the end of this webinar. And for this, you can use the question possibility that then we will be able to choose of or raise your hand so that we can welcome the different questions. So now I welcome Anil Goyal, research scientist at NEC Laboratories Europe. Since October 2018, Anil is working as research scientist at NEC Laboratories in Europe, in Heidelberg, in Germany. He is a member of an AI Innovations Research Group. Prior to that, he obtained his PhD in computer science, machine learning from University of Lyon, France, master in computer science from NCMAG Grenoble in France, and he has more than 6 years of experience in the field of machine learning and its applications to multi-view learning, imbalanced data classification, transfer learning, ensemble learning, document classification, image classification, predictive maintenance, fraud detection, travel time prediction, and information retrieval. Welcome, Anil, and hear from you.
Thank you, Thomas, for introduction. So NEC is responsible for one of the innovations at COREALIS Piraeus port, and so we are developing the asset management predictor. So first of all, what exactly is preventive maintenance? So can you see my screen or not?
You're not in presentation mode, Anil. That we can see your screen.
Okay. I think I have some problems here.
And if you press S5, F5 just to be able.
Now is fine. No.
No,
I don't have F5 because I'm on Mac. So okay. So now, so currently, so we are developing a predictive maintenance module. So for this, so what we have, so first of all, we need to define what exactly is the predictive maintenance. So in usual scenario, in predictive maintenance schedule, in maintenance scenarios, what we do is a preventive maintenance, where usually an engineers regularly goes to inspect some vehicles every couple of months, but there can be chances that there are no failures, and we waste resources by sending engineers, and this process involves a lot of money, and this process is kind of costly, and also it does not capture so the future predictions based on asset specific conditions of the different vehicles. Like some vehicles can be more aggressively used based on the number of rides, or there can be more heavy loads on some of the vehicles, and weather conditions can change how vehicle is used. So this kind of maintenance, like preventive maintenance or schedule based maintenance, is not effective in the terms of cost and the resources. So therefore we need some kind of predictive maintenance, smart maintenance, where we can predict in the future. So here comes the role of the predictive maintenance, where we take into account the past data to predict failures in the future. And the data set involves we make use of two kind of data set. One is the equipment data set, which we obtain. If you see a figure on the right, so we obtain the figure, we obtain the data set from equipments, for example the sensor data set, for example some kind of acceleration data set or weight data set or RPM values. And also we use maintenance data set, where we have past schedule of the maintenance, where we have past failures of the trucks, and based on that we pre-process. In the second step, we pre-process the data set and train a machine learning model or a AI model or a smart model which can predict failures in the future. So based on these failures, we can predict, we can have three kind of outputs. First of all, predictive maintenance schedules in the future, and then we can, based on the schedules, we can have an overview of the assets which can be used by the port authorities to track the individual vehicles or the individual parts. And based on the failures and the tracking, we can optimize the purchase in the inventory. So there are three possible benefits of the customer values for this predictive maintenance. First one is reducing asset downtime. For example, if we can have we can predict failures in the future, so there would be a reduce in the downtime of the vehicles. In the case of preventive maintenance, this is not the case. There can be failures immediate failures, and the asset can have no operations, and there can be downtime of the assets. And the second benefits is the reduce in the maintenance and the repair costs, where we have in the predictive maintenance, we can instead of sending engineers at the regular intervals every couple of months, we can reduce the maintenance or the repair cost by sending engineers calling engineers only the time when it is required. And the third benefit is the optimization of the spare parts inventory, where we want to based on the schedules, we can in advance buy buy some parts of the vehicles which can be used in the future based on the predictive maintenance. So coming to the market analysis, based on our market analysis, so there is a expected growth of 25 to 30% in compound annual growth rate by during the period of 2020-25, and it has a diverse market size in different applications, different scenarios like transportation, etc. And also predictive maintenance is a kind of from machine learning point of view or a data analysis point of view, predictive maintenance is a imbalanced classification problem. For example, here what I mean by imbalance is that we have a very few number of failures as compared to the normal working parts. So this makes the problem very challenging, and therefore we need solutions which takes into account this imbalance between the failures and the normal working parts. So from our to our best knowledge, whatever from the past, by looking into the patents and the other research paper from the other companies. So the normally the PDM solution relies on the advanced statistical analysis, but they don't really relies on the advanced machine learning technologies, which is tailored specific for the imbalance classification problem, where we have very few number of failures as compared to normal working parts in the case of predictive maintenance. So therefore, in this COREALIS innovation, we drive a special machine learning algorithms tailored for this problem. So coming to the technology, what we do is that Bright is a kind of a umbrella of algorithms which is developed by NEC, which is a ensemble learning algorithm technology. So what is ensemble learning? In usual, what we do is that in machine learning, we learn a particular function, or in other words, a classifier, which predicts future failures in this case, or which makes predictions in the future. But in the case of ensemble learning, we learn a set of classifiers which can be combined together, which can have a better learning in the future. So Bright is a set of classifiers which is a kind of a ensemble learning technology, or which relies on a combination of the classifiers, and it consists of multiple algorithms. So one of the algorithm which we have developed as a part of COREALIS innovation is Bright DAMV, which we called as a DAMV algorithm, which is a especially tailored for imbalanced data classification. And this work has been validated on multiple applications apart from predictive maintenance, like credit fraud detection, medical diagnosis, and web page classification, which are also an imbalanced data classification problems. And this work has been accepted at CoreAnK conference this year. So coming to the little bit details of the algorithm. So we have for example, if you see in on the right this figure, so we have kind of this algorithm can be seen as a three-step algorithm. First of all, we learn a set of base classifiers using a multiple data sets of the multiple input data sets, and then we reweigh somehow the examples, which increases the weights of those examples which are hard to classify, and then we finally learn a combination over these classifiers, which is tailored towards imbalanced data classification problems. So this is the very brief introduction of the algorithm. And coming to the experimental results, as I said, that we have validated on multiple data sets, like 6 data sets, where we have imbalance ratio. So here what I mean by imbalance ratio is that how much percentage of minority class example we have in the data sets, like in PCT data set. So this is the data set which we obtained from Piraeus container terminal in Greece, and we have the imbalance ratio of 0.02, which means that there are only 0.02% of failures in as compared to the normal working parts. And we make use of 17 features attributes, which is a kind of a 17 sensor data values which we have obtained from the trucks. And based on this thing, we compared our algorithm on with various state-of-art technologies which are based on imbalanced data classification, or for this kind, which are suitable for these kind of problems. And we show that experimentally we are better than the baselines in the terms of average precision and F1 score on almost all the data sets. And these two KPIs take into account the number of false positives and false negatives. So this is the novelty, and this is the innovative part of our algorithm. And we have also validated this algorithm on multiple data sets. For example, we obtain another Scania, openly available Scania predictive maintenance data set, which has imbalance ratio of 1.67%. Also, we show over there also we perform well on this task, and also on credit fraud detection and cancer detection data sets. Now coming to the web interface, which we have developed as a part of which is a kind of a software development. So we have developed a graphical user interface using HTML and other Python libraries. And so this is how it looks like. On the first step of the predictor of the software is that we can check whether for a particular part we have already trained model or not. So based on that, we can see when the model is trained in the past and at what time, so that we can update the model at the regular intervals. And the second step, we need to validate whether there is a at the required location the data is available or not for the training of the new model. And then to train the model, we have we give the user a flexibility to train the machine learning model. So for a particular part ID, for part ID of the trucks, in this case, we can train for each part we train a individual model, and we give the user flexibility to in how much advance the user wants to predict the failures. Like in this example, we show that we want to predict failures 14 days in advance. And similarly, the part IDs can be comma separated, where you can train part IDs parallelly, which is given as a parameter how many part IDs you want to train and how many CPUs you want to use for the parallel training of the models. And then finally, we can predict the failures for that particular part ID for the new data, and then based on that failures we can make decisions. And also along with the failures, we also give the probabilities of the failure, saying that how much probable, what are the chances of the failure of that particular part for a particular vehicle is going to happen, and in how many days. So based on this thing, port authorities can optimize the inventory, can send the required number of engineers, etc. So yeah, so this is the software developed by as a part of COREALIS. So yeah, so thank you for your attention. Yeah.
Thank you, Anil. And we have already some reaction on predictive maintenance, an interesting additional tool to perform predictive maintenance. But to our experience, it does not exclude, however, physical checks. For example, on heavy port equipment such as mobile cranes, conveyor belts, samples of lubricants are often taken to analyze if they contain metal particles within acceptable range. If not, a deeper analysis, of course, is needed. Before I ask your comment, Anil, I will launch a small poll on this. Okay? So we ask you, is the presented innovation already deployed in your port? Interesting and is being prepared to be deployed in your port? Interesting and not yet deployed in your port, or not applicable at all in your port? Can I invite you to vote? Only 20% have voted, so I invite you to vote yet. May I encourage you to vote? Okay, we've only reached 25%. 28%. Okay, I give 3 more seconds, and then I close the poll to continue. Okay, I close it, and now we can see that it is for 20% already deployed in the port. For 30%, it is interesting and it is being prepared to be deployed in the port. 40% say it's interesting and not yet deployed, and 10% say it's not applicable in your port. So Anil, may I ask you, it doesn't prevent to do some physical checks. Can you answer this? How can it accompany the physical checks and normal maintenance work?
So of course as predictive maintenance predict failures in the future. So we don't have to, so for a particular part, we don't have to do the maintenance work. If we have the model for each part, for example, as you took an example of conveyor belt and all. So if we have maintenance model for that part, so predictive maintenance can stop doing can help to reduce the maintenance work for that particular part in the future. So this is my comment. So based on the predictive maintenance and how much prediction horizon you want to predict. For example, in my slide, I have shown an example of 14 prediction days. So over there in prediction horizon, so in advance we are predicting in 14 days and also with how much probability. So based on that, we can analyze when to send the engineers to do a maintenance work. So this is how predictive maintenance will reduce the maintenance work.
Okay, thank you very much. I see there is no additional question for the moment. You may reserve these for the end of the webinar. We will now switch to the next innovation. Thank you, Anneliel.
Thank you.
Sven de Brucker from DINIC is Senior R&D Engineer. He was born in 1980 in Belgium, received his Master of Engineering degree in Electromechanics in 2002 from Den Hayer College in the University, and Master of Science degree in Electrotechnical Engineering in 2005 from the KU Leuven in Belgium. He did do then afterwards a PhD in Electrotechnical Engineering on the impact of current ripple on Li-ion battery aging in 2012. In the past, he worked on various topics, including power electronics, batteries, PVs, and electrical vehicles. He now works at DINIC Energy since 2017 as Senior R&D Engineer and works on traction solutions, AC and DC grids. Welcome, Sven. The floor is yours.
Thank you, Thomas, for the introduction. I will give a short presentation on the energy assessment framework. So the Green Cookbook is basically an energy assessment framework for ports in which we investigate the integration of renewable energy and storage within the ports in order to reduce the carbon dioxide footprint of the port, but also in a cost-effective way. In order to do this, we have made a simulation environment with a model which tracks the power flows between the main actors within the port, being the renewable energy sources, the battery, the load, and the grid. And it also imposes some constraints. For instance, the grid has a maximum power, the battery also has a maximum power, and the state of charge limits of the battery have to be respected. The model performs an optimization of several objectives. For instance, the self-sufficiency of the port needs to be maximized. The peaks of the load and the renewable energy towards the grid needs to be minimized. The cost needs to be minimized. And of course, the carbon dioxide or the harmful emission needs to be minimized. So although we have a general model, we have taken the example, the specific example of the port, the container port of Piraeus as an example. In this port, we have a peak consumption at around 7 megawatts, and the port consumes 40 gigawatt hours annually. 90% of the load in the port comes from the quay cranes, the yard cranes, and the reefer containers. And for this specific example, the load can be met by a combination of several renewable generations, being 10 megawatt of PV plants and 7 wind turbines of 3 megawatt, which gives a total renewable generation of 60 gigawatt hours. This generation is combined with energy storage. So we need a total of 7 containers to store 25 megawatt hour net storage of electricity. And we need 2 containers to deploy 12 megawatt of power from these containers. And all of this can be achieved with a grid connection power of 5 megawatt. If we put the whole of this installation into work, then we can achieve 90% self-sufficiency of the port. so only 10% of the energy needs to be imported, and 60% of the locally generated renewable energy will be used within the port. This also means, because we have 16 gigawatt-hour export and 4 gigawatt-hour import, that the port becomes a net exporter of green energy. And because we have taken the cost into account, we are able to achieve this at a very competitive cost, below 60 euros per megawatt hour. With this, we already can achieve 60 kilotons of CO2 savings per year. And this is due to the fact that Piraeus already did a lot of effort to electrify the cranes. So the K cranes, the yard cranes, all of them are already electrified. There is no diesel crane in the port. So this means that we can already save 320 rail cars of coal per year just by implementing the renewable generation with the battery. A next step that we can take is the electric yard vehicles. Currently, there are some 140 diesel vehicles in the port, which are subjected to a lot of stop and go traffic and which travel at low speed, which makes them very inefficient for diesel-driven vehicles. But it's the ideal scenario for electric vehicles. So what happens when we replace all of those diesel vehicles with more efficient electric vehicles? Well, we found out that this can be achieved at a reasonable price of only 10% extra consumption within the port. So we go from 40 gigawatt hours to approximately 44 gigawatt hours. And more importantly, this can be achieved with the same renewable installation as before. So the same 10 megawatt PV, the 7 wind turbines, and a slightly increase in the battery. And this is made possible because with the added load of the electric vehicles, we have 50% less curtailment. There's a better match between the load and the generation. And the remaining part of the EV load is covered by the import of electricity. And also because the load is bigger, we need to increase the grid power to 5.7 megawatts. But still, even these numbers, we can still achieve 87% self-sufficiency, 65% self-consumption of the renewable generation, which is quite a high number. The port remains a net exporter of green energy, although it decreases from 12 to 9 gigawatt hours. And more importantly, the price stays below 60 euro per megawatt hour, so we're still very competitive. So with these measures, we can save 2.5 million liters of diesel per year. And more importantly, it's also a good investment because most of these vehicles have a lifetime of 15 years, while the return on investment with the electric drive is only 4 years. So this is an impressive result. A third and last measure that we can take is the provision of an onshore power supply, in which we can shut down the onboard diesel generation of the ships and replace it with power supply from the shore to provide the electric loads within the ship. That there's a constraint if we try to implement this, because we only have currently a 7 megawatt grid connection, and we try to maximize the onshore power supply within these limits. We can do this with 5 extra wind turbines and maximizing the grid connection to its physical capacity of 7 megawatts. With this, we can provide 11 gigawatt hours of onshore power supply. which means in practice that we can supply approximately half of the ships that come to the port with an onshore power supply. The total renewable generation now becomes 90 gigawatt hours, of which 18% will be curtailed. We still have 80% self-sufficiency and approximately 55% self-consumption. The port remains a net exporter with 20 gigawatt hour annually of green energy exports. So to conclude, we can see that if we implement electricity generation with PV, wind turbines and storage at a competitive price below 60 euro per megawatt hours, and given the fact that the cranes and the reefers also are all electrified within the port, together with the electric vehicles and the onshore power supply, and the fact that the port becomes a net exporter of green energy, we can save up to 1,500 kilotons of carbon dioxide over a 15-year exploitation period, which is the equivalent of 8,300 rail cars filled with coal over the 15-year period. So it's quite an impressive achievement that can be achieved within the current constraints. So this was my presentation. Thank you for your attention.
Thank you very much, Sven. I see that there is no question yet that have come, so it seems all clear. Now I'd like first a quick poll. Is the presented innovation already deployed in my port? Interesting and is being prepared to be deployed in my port? Interesting and not yet deployed in my port? And or not applicable in my port? 15% have already voted. I encourage you to give your opinion. So 25%. I give some more seconds to vote. 30%, 32% have voted. Three seconds more. And I close the poll. So we see that for 31%, it is already deployed in my port. For 38%, it is interesting and being prepared to be deployed in my port. 31% find it interesting and it is not yet deployed in my port, and there is no one who say it is not applicable in my port. So Sven, it is very interesting. It can be also simulated, and I guess it is being also used for asset management, and it is a good introduction for the next speaker, where we will talk about the serious game. So thank you, Sven. And now I will welcome De Boer, who has about 10 years of professional experience in harbor and coastal engineering. After his master in science degree in civil engineering and management at the University of Twente in 2009, he worked 1 year as a researcher at the same university. Currently, Liebe works as senior project manager and advisor at Harbor, Coastal and Offshore Engineering Department of Delta RS, independent research institute. He has international experience on projects related to port infrastructure, sustainable port development, nature-based solutions, and coastal erosion mitigation. Furthermore, he has a part-time research affiliation at Delft University of Technology. Wiebe is a research and development coordinator of future-proof coastal infrastructure, project leader of the Port of the Future serious game, and project developer at Smart Port on innovation projects in the Port of Rotterdam. In his work, Wiebe strives to apply new technologies and integrate knowledge from different disciplines to solve both today's and tomorrow's challenges. including sustainability and climate change adaptation. Welcome, Wiebe. The floor is yours.
Thank you, Thomas, for the nice introduction. I hope you can all see my screen at the moment. Before I start talking about the Port of the Future series game, Thomas, can I ask you to launch 2 polls that we prepared to check the opinions of the audience?
Yes. So, which challenge do you consider the most relevant for your port business? Digitalization, energy transition, climate change adaptation, sustainable port city development, or other? I see that 19% have already voted. 30%. I give some more seconds. So 42% have already voted. I close the poll in 3 seconds. And I close the poll. So we see that digitalization is for 47% the biggest challenge. Energy transition, 21%. Climate change adaptation as such is 0%. Sustainable port city development for 32%. What is yours?
Yeah, can you also launch the second poll, Thomas?
Yes. So what do you currently do on stakeholder engagement in these transitions? Information brochures meetings? Serious gaming? Only what is required by legislation? Stakeholder workshops focused with group discussions, or nothing? I encourage you to give your opinion on this. So 15% have already voted. 23%. I give some more seconds. I'll close the poll in 3 seconds. And I close the poll. So, information brochures on meetings for 50%. Serious gaming is already for 7%. Only what is required by legislation for 14%. Stakeholder workshops or focus group discussions for 64%. Or nothing, 7%. Wiebe, floor is yours now.
Yeah, thank you very much, Thomas. Thank you for voting. So 7% for the Port of the Future series game. So I know a little bit what my mission is in this webinar. I'm going to present to you the Port of the Future series game that was developed as part of the COREALIS project. So first of all, why did we develop this game? The motivation is actually that we see that there's a lot of ongoing port developments within Europe, but also outside of Europe to accommodate for economic and population growth. And there is more and more focus on what they call inclusive green growth. So apart from, let's say, the economic considerations, there is more and more attention also for environmental and social aspects. And they also refer to that as the triple P, people, planet, and prosperity. Another thing what is going on is that there's new challenges. Those challenges you also voted for. So digitalization or emerging technologies is one of the biggest, you said, but also the energy transition is an important trend, let's say, and also climate change for some people is now important. It was not voted for very highly, but that is one of the things that ports start to think about. So with this in mind, we started to develop a Port of the Future series game to motivate ports to think about their future, to think about these aspects for people, planet, and prosperity, and to solve or combat these new challenges. So, what are the objectives for the Port of the Future series game? What we try to do with this game is to especially raise awareness. So, what is going on in ports and what could all these challenges mean for ports? And we do that by simulating real-world events in a digital simulation environment. Another thing what we aim to do with the game is to involve stakeholders. So together with a group of stakeholders, and unfortunately we cannot do that today live, but well, I will try to give you a little bit of the experience with this presentation, explore what the port of the future should look like, and do that together. And it can also be used for education purposes to stimulate multidisciplinary thinking. So think not only about the technical or economic aspects, but also about the social and the environmental aspects, and to approach the problem from different stakeholder perspectives. So that is what we aim to do with the game. So what is this game exactly? Well, here you see a screenshot of the digital simulation environment, and it's a fictitious port. And we did that deliberately so that we can use this game for any port in the world, and also to move the stakeholders a little bit out of their comfort zone and to think freely about the port of the future. So for this fictitious port, there are different stakeholder groups, and let's say the players are subdivided over these groups, so that can be governments, port authorities, but also NGOs or terminal operators. And all those stakeholders have to think from their stakeholder perspective how their port of the future should look like. And they can influence that port of the future by taking measures. And you have to negotiate with the other stakeholders about these measures. So the game consists of several rounds, and in these rounds, only 2 measures can be selected. And the stakeholders need to discuss and negotiate which 2 measures they are collectively going to implement. So you need to convince each other with good arguments, and you also need to step in each other's shoes to, well, think a little bit, okay, what will they need, or what will they see in the port of the future? So that is, well, what the game is all about, to stimulate this debate and to start thinking together about this port of the future. Well, the measures that can be selected are a very wide range. So it can be about port expansions, can be about hinterland connections, environmental measures, but also, let's say, port city measures. And these measures are scored on the, let's say, the 3 Ps that I introduced in the first slide, people, planet, and prosperity. And we used several KPIs for that. So for the people, we look at employment, recreation, and safety. For planet, we look at ecosystems, emissions, and climate vulnerability. And for profit or prosperity, we look at the port profit, but also the benefits to the port city and to efficiency for the port. So, well, this whole process is then about, well, thinking or exploring the port of the future together, and to kind of balance these people, planet, and prosperity indicators. And that is facilitated by a facilitator who well, plays an important role in this gameplay, because he should activate the people to think about these things, but also reflect on well, what happens, how measures affect these scores, to make this an interactive workshop or experience. So that is the basic gameplay, let's say. Furthermore, we have incorporated together with the living labs that are associated to the Port of the Future series game, some scenarios and events. And those scenarios and events are meant to make the, let's say, gameplay more tailored to the specific context and challenges of the port. So we have a number of scenarios, and those scenarios are, let's say, in line with the trends and challenges that we discussed on the first slide and also in the poll. So it's about climate change adaptation, energy transition. It could also be economic stagnation, and well, at the moment that is actually quite relevant due to the coronavirus. It could be about innovation or digitalization, which is a major trend in most of your ports, and also about sustainable port city development. But we also included a neutral scenario, and it is just, well, that there is not really a starting point, so that we can basically play it neutrally if that is what the port wants, basically. Why these scenarios? These scenarios basically trigger a certain type of thinking in the gameplay, and that can be further triggered by events. such as, for example, that the jobless rates are very high, or that the hurricane hits the port. So these are basically unexpected events that can happen throughout the gameplay to basically stimulate different thinking, or to highlight that there is more to a problem than only one direction. So, for example, if you think about the energy transition, if the players focus too much only on the transition to renewable energy, and they, for example, forget about employment or education of the employees, then there could be an event that there is a strike, for example, and then well, the players have to deal with that and then hopefully take different measures. So that is a little bit how this game works. Well, the whole idea was of this demonstration that we would play this live with you, but that is not feasible in an online event. So I made a very short movie that, well, shows you a little bit of a fly-through to the game, but, well, you miss all the, let's say, interaction and discussion. So I will just talk you through it a little bit. So what you see now is the start screen. So you play a scenario. Then based on the needs of the port, you can select scenarios from a list. In this case, the climate change adaptation scenario is checked. And then you see that the PPP scores are affected according to that scenario. And that already triggers a little bit, okay, we may need to do something about our planet, for example, in this case. And then people can select measures. So this is after all the discussions have taken place. In this case, port developments are selected. And then the players will get official feedback of this measurement. So in this case, of this measure. So in this case, you see a brownfield port development where, let's say, an old industry is replaced by a new logistic hub. But it could also be a new port development, like an island port development, what you see here. And you see below in the screen how that affects the scores on people, planet, and prosperity. And this will also change the scores here. And you see that these measures, for example, didn't really work out for the planet. So then people have another round where they can rethink or reconsider their considerations of their choices. And then, for example, in this case, they select electrification of port equipment, which links to what Sven was just talking about, and green space. And you see now that it has a positive effect on all the indicators in this case, the electrification of port equipment. Well, the same is for the public green space, which is has a positive effect on people and prosperity, but just a neutral effect on planet. And then you will see after that round how that affects the scores. Well, this went very quickly, so you won't see it. And at the end of the game, you can see what basically happened. In this case, we had 4 measures. You see the scores changing, and you can also reflect, let's say, on the events. I didn't show you any events now, but, well, that can be something that you add to the game. So, very brief, very quickly, how this game works. As I said, we miss a little bit the main thing of this, and that is the discussion and the reflection of the game, which, well, should be part of an actual gameplay. Okay. Oh, sorry, to finalize, some concluding remarks. Well, the focus of this game is especially on raising awareness and to explore, let's say, alternative futures for the game. It's not as such a decision-making tool, because the numbers that you get out of it are qualitative rather than quantitative. So it doesn't give you, let's say, the facts and figures to base a decision on, but it gives you the mindset to think about the future. The feedback that we got from past experiences, both in the COREALIS consortium, but also with its predecessor, with some game sessions that we played in Latin America or in Indonesia, is that it is a very nice and interactive way of learning about port developments and challenges, and it helped to better understand port sustainability, different stakeholder viewpoints, and also to think differently. So in that way, the game can be very helpful as a starting point, let's say, for further stakeholder engagement to think about the challenges of the port. If you want more information about the game, I refer you to the COREALIS website or our own website with the links you find below. And then I want to thank you for your attention.
Thank you, Wiebe. And now a small poll. Again, is the presented innovation of serious game already deployed in your port? Interesting and is being prepared to be deployed in your port? Interesting and not yet deployed in your port, or not applicable in your port? I see that 15% have already voted. 25%. 30%. I give some more seconds. 3 seconds to go, and I close the poll. And I close the poll. So it is already being deployed in your port for 0%. Interesting to know, because it was mentioned that it was already being done for 7% before the presentation. It is interesting and is being prepared to be deployed in your port, 20%. Interesting and not yet deployed in your port for 70%, and not applicable in your port for 10%. We have already one question. How deep does the analysis go, Wiebe? For example, on electrification, does it consider the source of electricity, wind power or coal-based?
No. It's very, let's say, high level. So it's really basically it considers the primary effects, but it doesn't really include what source was used to for the renewable energy to electrify the port. So that part is not in there. So therefore, you need, for example, an in-depth analysis by the tool that Sven just showed.
Okay, thank you very much. Is there any other question for Wiebe? Then I will go back now to Sven, because there was already a question asked some minutes ago to Sven.
Yes.
So 2 years ago, onshore power supply, we did a project concept of putting containers with loaded batteries on small ships that can connect them to the main ship on the other side, not on the quay side. The empty batteries of the small barge were then recharged at night during weekends. Is this also an idea, and can it be integrated in the grid?
Yes, it would also be an idea to integrate shore power for the ships, but you have to take into account that the same restrictions apply. As so, for instance, we see in the port of Piraeus that already the maximum amount of electricity that can be delivered to the grid has been reached, so we cannot provide more electricity to the ships. And moreover, because you are using batteries instead of a direct connection to the grid, you have more losses. So first you will charge the battery, then you go from the battery to the ship. So you will have more conversion losses and storage losses in your storage. So that means that even the amount of ships that you can apply with the shore power can even decrease because of that. So I think I prefer a fixed shore power connection, depending, of course, on the possibilities for it on the case and so on.
Okay, thank you, Sven. Is there any other question? You can now unmute yourself and ask the question directly to the speakers. And I invite the different speakers to come back as on the panel. No hands raised. No question. So I have already a question. It was about the results. I saw that we had very good results. Anil, Sven, Wiebe, and Stavros. I do believe that there are many other things being planned for the port of Piraeus. What is the most interesting, Stavros, for the port?
I believe all the three living labs are interesting because, for example, if we take the Predictor and we use it on the port, we will have more space to store containers. So this is one thing that we are looking for. Also, the other living labs are very interesting because it's going to help the port socialize better with the surrounding environment and everything that already mentioned from the innovators.
Okay, so, and is there an interconnection between the different innovations that are being done?
I believe yes. The Green Cookbook, for example, is an assessment tool, and of course we have to integrate that to the simulation, the part of the future game, and see how this is going to work for us. So yes, I believe they are all integrated to that. Maybe not with a Predictor, but Predictor has other benefits, so it's also very useful.
Okay, and then it means that we, in order to have a good information or a good idea of what can be used as innovation, I guess that the series game is very interesting for that. How easy, how much time does it take to do a first series game for that?
Well, in principle, normally we say for a game session, it takes about 2.5 hours to have an effective game session. So that includes introduction and then you play a couple of rounds and then some reflection at the end.
Okay, but who should take part of the series game? Do we need a representative panel of the different stakeholders? How does it work?
Well, that depends on what you want to get out of it, of course. So if this is really to explore the future of a port, then we recommend to have, let's say, a representative group of stakeholders of that port as widely as possible. So a diverse group of stakeholders, not only terminal operators, but also not only environmentalists, let's say, but a balanced group of stakeholders. And well, you invite them. Normally we have a group of, let's say, about 20-25 people. And then we play this game in a session of about 2 to 2.5 hours.
Okay. Any question from the panel or any question from the audience? No? I don't see any yet. Sven, maybe a question to you. We see that the energy consumption in the ports is huge, and at the same time, the saving and also the challenges or the vision of the European Commission is also to reduce drastically the power, not the CO2 emissions, and therefore the electrical power supply will be done in huge stress. What are the main recommendations to how to plan better the overall picture?
Well, what we have seen in this Green Cookbook is that it's important to find the right mixture between the renewable generations that you have, that we provide more generation than the load on an energy basis, because there's not a perfect match, of course, between the intermittent generation and the load, because the load is quite constant and the generation is fluctuating not only during night and day, but also during winter and summer. And that you need to add some battery storage in order to improve the self-sufficiency, and that this battery storage is a very important factor. If you see at what you have achieved here, that the battery alone is responsible for a 10% increase in the self-sufficiency. And certainly, if you have a grid power that is less green, then those 10% can already make a huge difference. And because if you have 20% still coal-powered energy, then that gives you 200 grams per CO2 per kilowatt hours. Whereas if you can reduce that with a further 10%, then it's only 100 grams CO2 per kilowatt hours. And at the same time, we see that we don't want to make the battery too large, because then the cost becomes too high. But if you find the right mixture, then you see that 90% of the port can be provided with the renewable energy in the storage. So that's quite a high number that you can achieve within this industry.
Thank you very much, Sven. Is there any question from the audience? Yes. So regarding the two types of maintenance, preventive and predictive maintenance, what is the role of port energy manager in reducing the energy consumption and also lowering the number of breakdowns? This can be answered in two ways, either by Anil or by Sven.
I think
Anil is better suited.
Okay.
For energy management, I cannot really answer because I'm not so expert in energy management. But for the what is the other part? So can you repeat? So regarding the maintenance cost, right?
So regarding the two types of maintenance, preventive and predictive maintenance, what is the role of port energy manager in reducing the energy consumption and also lowering the number of breakdowns? So it is, you can take it as maintenance domain, and then I will turn back to Sven purely on the energy.
So regarding the lowering the number of maintenance, so it's kind of so as we are so we cannot really maybe we can lower down the failures in the sense that we are predicting in the future, so we can better take care of the vehicles somehow. And also regarding the maintenance, so we can of course in compared to preventive maintenance, we are of course lowering down the maintenance costs, because of the fact that in the preventive maintenance we are sending the engineers at the regular time, let's say every couple of months, to do a particular part maintenance for a particular part, which is many times which is not required because there is no failure, so then that vehicle does not require any maintenance. But in the case of predictive maintenance, we can reduce the maintenance in the sense that we are sending engineers only when it is really required. So when the failure is more probable to occur in the future, and then only we are sending the engineers. And also it can help us to based on the predictions, we can also optimize the inventory in the warehouses. So this can be the role.
Okay, thank you, Anil. Sven, maybe the energy side?
Yes, the energy management is more for the optimization of the energy flows within the port, but nonetheless there will be a huge impact on the maintenance in the port, because of course, for instance, if we look at the grid connection, nowadays it is used 24 hours a day, so it's more than 8,000 hours per year. But of course, if you switch to batteries and renewable energy, then maybe half of the time the grid connection will not be used because the load is covered by the renewable generation and the battery. So if you then apply predictive maintenance to the grid station, this can have a huge impact on your maintenance cost, because the amount of time that the grid connection is actually used is much lower. So you can use a predictive maintenance to see what the impact is on the grid connection, for instance. Also for the electric vehicles, there we already see, for instance, with electric forklifts, that with the electric drivetrain, there is less maintenance required than with the diesel vehicles, and that the lifetime expectancy of the vehicles also increases with the electric drive. So also there we will have to differentiate between the different drivetrains to see where the optimum is for the maintenance.
Okay, thank you, Sven. So we see here that the port of Piraeus, the Living Lab, we had 3 different levels of innovations. One very operation with the asset management. Then we have it somewhat medium term with the energy management. But we have also the serious game, which is the longer term cycle. And we can do already all 3 innovations and start implementing them now. How to interact and how to plan. There is a question that came to Wiebe, and what could be the role of the serious game in relation to the Green Deal and the Green Ports?
In relation to Green Ports, you said?
The Green Deal and the Green Ports.
Okay. Well, what the Port of the Future game can mean in there is that at, let's say, the first planning stages or the first preparing stages when ports are deciding about their strategy, how to become a green port or how to make use or comply to the Green Deal, is that you can bring together the stakeholders to see how they think about this and to see what is the best fit solution, let's say, in a local context. And so that is not really technically yet, especially about, let's say, stakeholder acceptance, let's say, or stakeholder views. You can in these first stages explore how they think about that. And you can at the same time also use it to raise awareness and to basically educate a little bit them what are the possibilities and what are the impacts more or less of these measures that you take. If you really want to go to the implementation stages, then you need, let's say, tools on a level like Sven or Anil to really provide you with the facts and figures to make, let's say, an investment decision.
Okay, but then it turns back. We get another question. What about energy consumption in supplementary tasks, activities inside the port? Trains in the port, or all the decisions that could be raised within the serious game into the energy management then. So we now add additional actions. For example, new trains in the port, it has an impact also for onshore power supply. It has also an impact on the in port's energy grid. How can be the energy consumption in supplementary task be planned and taken over?
Yes. For energy management systems, it's important that you have some kind of idea of the prediction of the load and, of course, the renewable generation. So if you increase the load into the port, then it will be important to make an assessment beforehand of what you can expect for the onshore power supply and make this as an extra input into the energy management system. But of course, it's a rather predictable load, so it's not easy, but you can deal with it because you know when the ships will arrive, and then you know, for instance, that during several hours they will be connected to the grid and draw a certain amount of power from the grid. So it's a rather well-defined load, and that makes it easier to incorporate.
Okay, thank you, Sven. Is there any other questions from the audience? Yes, another one is did arrive. In a context of a port like Piraeus that is expanding so much the last years, how realistic is an investment in renewable energy in terms of size and so on?
Well, we've seen already that with the example of the current load, and then you switch to the current load with the addition of the electric vehicles, then you can see that the same amount of generation can be used within the port. And if you look at a growth scenario, then you see, for instance, that you can install several megawatts of photovoltaic generation inside the port. For instance, the port has office building and more importantly a warehouse, and soon there will be a second warehouse. We've already seen in the simulations that if you completely fill the roof of those both warehouses with PV, that it's easily absorbed within the current load of the grid. So I wouldn't worry too much about the amount of renewable energy that I can put into the port. There's quite a big load already present. So you can go very far before you run into troubles with renewable generation. And also, we defined that, for instance, the 7 wind turbines are sufficient to achieve quite a high level of self-sufficiency in the port. This is also being done in other ports. For instance, if we look at the port of Antwerp, they have a total of 55 wind turbines already installed in the port. So we see that it can be achieved within ports. Also, the port of Rotterdam, for instance, they see that they can probably implement some 50 to 100 megawatts of PV within the port. They think it's feasible. So the numbers we used in the Green Cookbook are really realistic figures. We can see that from other ports.
Thank you, Sven. Any further question from the audience? We approach the end of the session of this webinar. I'd like just to mention that it is all supported by the Academy by Artico Partnership. It's a really partnership with local cities, local public authorities, service suppliers, also telecom companies, and all can be found back in artico.com, the Academy. And it's training in smart and sustainable mobility, face-to-face and online, designed for public authorities in Europe and beyond, on-demand and interactive sessions. And all the material will be found back on the project website. You can also follow us on Twitter, also on YouTube and on LinkedIn, as here mentioned. I'd like also to announce the next webinar on June 19th at 10 a.m., where we will talk about the sustainable is the new smart at Livorno port, 5G enhancing terminal operations, and also optimization planning tool for city operations. Thank you very much. I see that there is a last comment, or not last maybe. Thank you for your interesting webinar. How can we play the COREALIS game? I propose that you connect with through the LinkedIn or mail at info@list.corealis.eu, and there we can connect you with the different speakers or companies, just to making sure that you can have the good answers to your question and to your needs. Is there any further question? Then I'd like to thank you very much, the whole audience. Also, John, happy birthday, because it's today. I do believe it's a good start of a webinar. I don't know if we can still see you, but happy birthday to you and a good continuation. Thank you all speakers for this interesting session and webinar, and all the best for the next innovation and implementation in the different ports. Thank you, and bye-bye.
Thank you very much.
Thank you.
Okay, thank you.
Thanks.
Bye.